Hey guys, welcome back to Weld.com. So in today's episode, we're going to talk about a vertical beam splice. So this is something typical when you do rehab. This isn't really a connection that you're going to make for new construction. A lot of times they'll just have plates and it'll be a bolt-up connection, so it's already done in the shop before it gets on site. But today we're going to go ahead and kind of show you. We've done videos in the past where we use backing strips, and a lot of people are like, why do you use backing strips? Why not just run an open root? There's a couple of reasons we're going to do that. It's going to be for speed. These weld procedures, they're not really designed to show off your skill set as a welder. Typically on a job site, you're going to have one type of rod, 70-18. So you're not going to be mixing 60-10 rods, 70-18s, and all that in structural steel connection nowadays. So what we're going to do is we're going to cut in little rat holes in this piece right here. Same thing here. I'm going to show you exactly what those are. We're going to put this backing strips in there, show you where they're actually utilized, and we're going to go ahead and make this beam splice. So I went ahead and cut out what we call a rat hole. So this is just a little area right here that's going to allow me to put my backing strip in here. So I'm going to go ahead and take a grinder now and just kind of detail these out, clean them up. I want to radius this a little bit more. That I didn't get quite the radius that I wanted on this one, so I'm just going to clean this all up with the grinder. We got some really cool discs by Ferd that have a radiused edge on them that are meant to be used on end. So that's what I'm going to use to clean this up. I just want to make this a nice flat surface. And I want a radiused transition. That way I don't create a stress point right here, because anytime we have a 90-degree angle or an acute angle, it could cause tearing later on down the line when the load is applied. So I'm just going to go ahead and radius that out. That's going to help distribute that load so we don't get any cracking or ripping. As I'm cutting this out, I don't want to take too much material out of the web. That's why I'm trying to keep these holes small. I just need enough material taken out to be able to insert the backing strips. I also don't want to gouge into the flange at all. I want to keep that as structurally intact as I can. The next step, once I got everything cleaned up for my backing strips that are going to go in there, I'm going to go ahead and clean out the web of the beam to be able to accept the stiffener plates that we have. While this beam is laying in the flat position, I'm going to go ahead and put the backing strip on there and get them tacked in right here on both ends. That way when I go ahead and set the column in place, this work's already done for me. I don't have to try and line anything up. I'm going to go ahead and probably space this out with about an 1/8 inch, 3/16 gap, and then we'll go ahead and weld it out. I'm going to do the same backing strip to put to both sides. First, let's address the size of this beam. Obviously, this is really small. We're doing it on a shrunken down scale because this is the type of material we have in the shop. We don't really have a need for huge sections of I-beams, nor did it make sense for us to buy one, because you typically have to buy 20 foot. We only needed a couple feet to do this demonstration for you guys. But this is pretty much how it would go. Obviously, the thicker the material, the more welds you're going to have to do. You're still going to run your different bevels or your 45-degree bevel for your connection here. This is still going to remain 90 degrees. What I'm going to do now is clamp a piece of angle iron up here. That way when I bring the other beam in, I can kind of use this to clamp the other beam in place to mate these two pieces up. Obviously out in the field, you're going to have a crane or something carrying that. This is light enough to where I should be able to just pick it up and manhandle it. This is a W10 by 15, meaning the depth or the width of the I-beam is 10 inches and it's 15 pounds per linear foot. If you guys have more questions on structural steel, you can go back and check out the structural shapes video. So I'm going to use this 1/8 inch piece of plate to set my gap. I can just set that right here, put the column on top, clamp it in place, get everything clamped up, and then just kind of yank this guy out. But that'll help me maintain that 1/8 inch instead of trying to get it in here and then level it back and forth and kind of jockey around with it. All right, so we put a couple clamps on it. Now we're just gonna make sure everything's level, which we're good. Columns is in line with the bottom half. Everything's leveled, we're good to go. So I'm just gonna tack right here on the opposite side of the backing strip. You know, that way everything's nice and the same and it kind of leaves that little opening up. So as you can see, here's where our backing strips come into play. So it's just like anytime we do a horizontal test plate, vertical test plate, there's my backing strip right there, run on and run off tab. And once I get done with this, I can cut that off flush with the beam, and then I'm just gonna radius and dress up the corners a little bit. All right, so I'm gonna be welding it up with these Bowler Fox EV50 7018s, 332 diameter, running about 85 amps in the horizontal position on the Power Arc 161 STH from Everlast. All right, so went ahead and got the root in. I'm gonna go ahead and probably do a 2-bead cap. I got a little bit more space here. So instead of trying to run a weave on there, which I'm not partial to, I'm gonna go ahead and run 2 stringers. So we got the 2-bead cap in. I'm above flush, no more than 1/8 of an inch. I mean, I'm just past flush, so everything's good there. One thing I do wanna point out, I have a little bit of porosity right here where I started. And that's another advantage of my run on and run off tabs, because I'd rather have that porosity in this area where I'm gonna cut it off than trying to start my initial arc right here and running the chance of getting a little bit of porosity in there. Because it's on that run on tab, it's gonna get cut off, it's not gonna affect the weld at all, and it's structurally sound. Now we're gonna go ahead and do the exact same thing to the other side. All right, we got both the grooves welded out on our horizontal. We're gonna go ahead now and put our splice plate in. This is just for structural reinforcement. So typically you wouldn't go ahead and run that open root or run a seam right across there, or a cover pass or anything. You're actually gonna use a plate. We'll weld it on all 4 sides. You'll do one on the front and the back. So let's go ahead and get these tacked in and welded out. So as I'm going through these, there's really no rhyme or reason which one I did first. I decided to go ahead and knock the overhead out, just get that out of the way, because I put one tack down here, and instead of putting another tack over here, I could just start and kind of go through. I'm probably gonna go ahead and feather these top 2 tacks out here, weld the flat or the horizontal here, and then come back and catch the 2 verticals. All right, so the splice plate is on. The only other thing we would have to do now is put the other splice plate on the opposite side, but it's just a repeat of what we just did. So just know that you're probably gonna get one on either side of that. Now I'm gonna go ahead and show you guys how we take off the backing strips and just kind of radius this out and make it, clean it up a little bit. So that's pretty much the end of a column splice, at least in a vertical connection anyway. Like I said, I've done this a bunch of times out in the field doing repairs. The web of the column gets deteriorated, or the flange or whatever. We would come in and cut it down to size, cut a chunk out, and just replace that section of it, and this is exactly how we would do it. So hopefully that answers some of the questions of why do we use backing strips? Why don't you just run it open root? There's actually a practical means to it. So this is just one example of that. All right, so I hope you guys learned a little bit more about the purpose of a backing strip other than it being performed on a test plate. I hope you guys enjoyed the video, and until next time, make your weld better than your last.